Welcome to another video on engine drawing, and in this video we'll be learning how to draw the displacement table for a cam profile. There are four motions which a roller undertakes in a displacement table or in a cam profile, which are uniform velocity. Second, we have simple harmonic motion. The third, we have uniform acceleration and retardation, and the fourth is cycloidal motion. First, we'll be treating the uniform velocity. Using this question, design a radial cam to impact the following motion to a roller follower whose line of action coincides with the camshaft. 0 to 120 degrees lift on 24 mm with uniform velocity. 120 degrees to 180 degrees dwell. 180 degrees to 360 degrees fall on 24 mm. The diameter of the roller follower is 19 mm and the cam rotates anti-clockwise. The least cam radius is to be 19 mm. So the first step is to draw the displacement diagram, and after drawing the displacement diagram, we draw the cam profile using the displacement diagram. First of all, we write down our parameters. Once again, the question says, design a radial cam to impact the following motion to a roller follower whose line of action coincides with the camshaft center. A stroke, which is 0 to 120 degrees lift of 24 mm. The dwell is 120 degrees to 180 degrees. And last, we have the return stroke, which is 180 degrees to 360 degrees. We take the subtraction of this and this and this to get the actual A stroke, dwell, and return. Now our A stroke becomes 120 minus 0, which is 120 degrees, and dwell becomes 180 minus 120, which is 60 degrees, and the return stroke becomes 360 degrees minus 180 degrees, which is 180 degrees. Next, we draw the displacement table. Before we start the drawing, first we take a scale. We are taking a scale so that the displacement table can enter the sheet. Let's take a scale of 1 centimeter. Before you take a scale, you look at the parameters and check if the scale can enter these parameters. Let the scale be factors of these parameters. We'll be using 1 centimeter to represent 20 degrees. That is, each of these parameters can be divided by 20 degrees and get a whole number. First of all, let's get the A stroke, dwell, and return stroke all in millimeters. so that we can draw it on the displacement table. This will be 120 degrees divided by 20 degrees. Six millimeters. 120 degrees divided by our scale, which is 20 degrees, gives us 6 millimeters. The dwell, which is 60 degrees divided by our scale, 20 degrees, gives us 3 millimeters. And the return stroke, which is 180 degrees divided by 20 degrees, also divided by our scale, gives us just 9 millimeters. Let's all convert this to centimeters, because it's centimeters we'll be using to draw. So 6 divided by 10 to get our, sorry, this is in centimeters. All these are in centimeters because we are using 1 centimeter to represent 20 degrees. So these parameters, that is, in each 20 you have in 120 gives you 1 centimeters. So that is 6 centimeters. All these are in 6 centimeters. Each 20 you have in 60 degrees gives you, there are 3 20s inside 60 degrees, which is 1 centimeter, 1 centimeter, 1 centimeter. That's 3 centimeters. Same here, 3 centimeters. Next, we convert our lift, which was given to us as 24 millimeters in the question, divided by 10, you get 2.4 centimeters. Next, we also, the total length of the x-axis is in 360 degrees. Also divides by our scale, which is 18 centimeters. Now we measure 18 centimeters on the x-axis. We measure the total length of the x-axis, which is 18 centimeters. From 0, you measure 18, this is 18, you mark it out. We measure the R-stroke, which is 6 centimeters. Also from 0, here, measure 6 centimeters, mark 6 centimeters on your meter rule. Now the next, you measure the dwell, which is 3 centimeters. From the point, from the R-stroke, measure 3 centimeters for the dwell. Next, we measure for the return stroke, which is 9 centimeters. From the dwell, measure 9 centimeters. This is 9 centimeters. Our lift is on the y-axis, which was given to us in the question as 2.4 centimeters. So on the y-axis, we measure 2.4 centimeters. On the meter rule, this is 2.4 centimeters. Now, after doing this, we'll rule a line from the 2.4 centimeters over here. Let's still measure 2.4 centimeters over here. At the end of the x-axis, I'll rule a line joining these two. Now you project lines upwards from each point. The R-stroke, let me label it. From here to here, from here to this point is the R-stroke. This point this, the dwell, and last of this to the ending is the return stroke. You project lines upward from the point of the arc stroke, the point of the dwell, and the point of the return stroke. Since this is a uniform velocity, it's just a line from the 0 point to the top of the dwell, to the highest point of the dwell. From here to here, you rule a line. From this point, the dwell, to the 0 point, which is the 360. Rule a line, and this becomes the uniform velocity. This becomes the uniform velocity displacement table. This is 120 degrees, I was forgetting. This is 60 degrees, and this is 180 degrees. So this is how you draw the uniform velocity motion for a displacement table. Now let's draw the cam profile. I'll read the question once again. Design a radial cam to impact the following motion to a roller follower whose line of action coincides with the camshaft center: 0 degrees to 120 degrees, lift on 24 mm with uniform velocity, 120 degrees to 180 degrees, dwell, 180 degrees to 360 degrees, fall on 24 mm. The diameter of the roller follower is 19 mm. So we're given the diameter of the roller follower to be 19 mm. Roller diameter 19 millimeters. Okay, and the cam rotates anti-clockwise. The least cam radius is to be 19 millimeters. So minimum radius of cam equal to 19 millimeters, and the direction is anti-clockwise. Okay, so these are the parameters we were given to draw the cam profile. So before we draw the cam profile, in a roller follower, we will need the prime circle, and the formula for the prime circle is the roller radius plus the minimum radius of cam. And the roller radius is given as the diameter divided by 2, roller diameter divided by 2, which is 19 divided by 2, which is 9.5. 9.5 plus this is already in radius, minimum radius of cam, plus 19 to give us 9.5 plus 19, that is 28.5. Alright, first off, we draw two perpendicular lines, X and Y. Right. Now first we measure the prime circle, which has a radius of 28.5. This is a radius because we calculated all in radius, so this answer it gave us here is in radius. So 28.5 in millimeters converting to centimeters is 2.85 centimeters divided by 10. So 2.85 on the meter rule, so 2.8 in between 2.8 and 2.9, get 2.85. Next we measure the minimum radius of cam, which is 19 millimeters. That is also 1.9 centimeters if you divide it by 10. You place it at the center line. Make sure you place it at the center line and draw. Alright. Next step, note one thing you should know in cam profile drawing is that the roller direction and the cam direction are opposite each other. If the cam direction is moving anti-clockwise, which is this way, anti-clockwise, which is this way, the cam will be moving in a clockwise direction because the cam is what is moving and the follower is stationary. So if the cam is moving this way and the follower is this way, that means the follower is moving in the opposite direction. If the cam is moving this way, the cam will be moving this way, the follower will be moving this way. So if the cam is moving this way, then the follower will be moving this way. They have opposite direction. Now they gave us the direction of the cam to be anti-clockwise, therefore the follower direction is clockwise. So we'll be taking our degrees, our measurements clockwise. Right. First off, let's draw our roller follower first, that we know. Roller follower is 19 millimeters, which is 9.5. So 9.5 on the meter rule. Which is this. So pin here on top of the prime circle and this horizontal line, and draw a circle. This becomes our roller follower. It becomes a roller follower. Now the direction is clockwise, therefore it's moving this way. Let's recall back to our question, our displacement table. Our R stroke here is 120 degrees. Our outstroke is 120 degrees, so we measure 120 degrees. Place it here. This is the 0 point of the outstroke. From 0, measure 120 degrees. I'll draw a line. 120 degrees. Right, we can erase this. It will be useful more. So erase this. Right, 120 divides by 6. 120 degrees divided by 6. Yeah, to divide the outstroke into 6 equal parts, and the outstroke is 120 degrees. So 120 divided by 6 is 20. Now outstroke 120 degrees. To measure 20, 2, 4, 6, 8, 10, 12. Now take these lines outward. Next, we measure the dwell. Now dwell is given to us as 60 degrees. So let's take for our outstroke, our return stroke is 180 degrees. Let's measure the dwell. Which is 60 degrees, that is here. To here is our dwell, 60 degrees. And of course, this is 180 degrees, and that is for our return stroke. I will measure, we divide the return stroke into 6 equal parts. 180 divided by 6 is 30. So divide into 6 equal parts, 30 degrees. So 3, 6, 12, 15. So take a stroke outwards from the point we measured. Right. Now the next step is to get our cam profile, which is gotten from the displacement table. Now, not forgetting, we also have to divide the outstroke here, the outstroke here, and the return stroke here into 6 equal parts. The measurement of the outstroke here gives us 6 cm. So 6 divided by 6 is 1 cm. So divide it by 6. Also, the return stroke is 9 cm. So 9 cm divided by 6. The return stroke here is 9 cm. 9 cm divided by 6 is 1.5. So that's our 1.5. 9 divided by 6. That's 1.5. Measure 1.5 on the x-axis. 1.5. 6, 1.5, 3, 4.5, 6, 7.5, 9. Measured it on the return stroke. So draw a line moving upwards, project a line upwards from the point you measured. Alright, now we can pick our points from the displacement table to draw on the cam profile, to get our cam profile. So first off, let's label this out. So 0, this is 1, 2, 3, 4, 5, 6. This is 6, 5, 4, 3, 2, 1, 0. Now let's also label the cam drawing. This is 0, is moving clockwise. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6, this is 6, 7, 8, 9, 6, 5, sorry, 4, 3, 2, 1, same 0. So from 1, you measure from the x-axis, pin at 1 and extend to this point here. From the stroke, extend to it. Now come back to your 1. From the prime circle, cut this stroke here. Let's go to the next. From 2, extend to the uniform velocity stroke. Come to 2 and cut this stroke. Mark it. Next, from 3, extend to 3 here. Extend to the stroke here. Same process. Pin at 3 from the prime circle, cut. Still do the same thing here. 4. Now extend from the X, extend to 6. Extend to 6. Pin at 6 here, cut. 6 is still have same measurement, so you pin at 6 and cut here. Now we go back to 5. Pin 5, cut here. Go to 4, extend. Just same process as we did. Last we extend to 1, then you mark at 1 here. Alright, now after marking, we can get our cam profile, and this is gotten by measuring the radius of the follower. First, measure the radius of the follower, get the radius of the follower. Now at each point, pin at each point, now draw the radius of the follower, or you can still draw an arc since it's just the base of the circle we'll be using. You can draw an arc. Let's draw an arc here. Same here. Alright, after doing this, now like I said, it's just the base of this circle we're using, the bottom of the circle, that was to be using to get this point, to get the curve, the cam profile. Alright, so from here extend. You can use a French curve, but in this demonstration I'll be using a rough sketch. I'll be sketching it. Since 6 to 6 have the same measurement, a constant measurement. Alright, sorry about that, the camera cut unexpectedly, but this is how we got the curve. As I was saying, you sketch, you can use a French curve or just use a sketch. Draw a curve that touches the bottom of each of the circles, each of the roller circles here, roller followers. Then you thicken the line. This is called the cam profile. That is our main focus, the cam profile. The pitch curve or the pitch curve is gotten from the centers of the roller followers. The center of the roller follower. Draw a curve, sketch a curve, or use your French curve to get to pin from every point, from each point of the roller followers, each point. That's how you get the pitch curve. You can use a dotted line so that you can differentiate the cam profile and the pitch curve. The cam profile is the main focus. The pitch curve can be asked sometimes. So these are the labels of everything here. First, this is the follower. This is the follower. The follower moves in the opposite direction to the cam. The cam, as I said here, is anti-clockwise. That is, the cam is moving this way. Is moving this way in this direction, while the follower is moving in this direction. That is why we have our numbers 0, 1, 2, 3, 4, 5. That means the cam is moving in this direction. This is the outstroke 120 degrees, the dwell 60 degrees, the return stroke 180 degrees. Also, we have our base circle, which is the small circle here, the smallest circle here, which is the base circle. Note the cam profile always touches the base circle. It starts from the base circle and comes back to the base circle, while the pitch curve starts from the prime circle and comes back to the prime circle. Alright, so this is how you draw the cam profile. This is how you draw the cam profile. Alright, thanks for watching. Do well to like, drop a comment, and also subscribe for more videos like this. Thank you.